All right, over you. All right, so welcome back, guys. Um, so hopefully everyone did well on the AMCs, those of you that took it. If you guys want, I could do like a class like going over the problems, but that might be outside the scope of this class. So they might be a little bit on the harder end. So yeah, let me know if you guys want me to do that or not. But yeah, so moving on. So, if you guys remember from a couple of weeks ago, we have we're on lesson 3 right now. We've had two lessons already. So today's lesson is going to be sort of the same as before. So we're going to start off with a couple of practice problems, and then at the end we'll do like a countdown round. And I've made today's problems a little bit easier just because some of you guys are probably still recovering from the AMCs, or some of you guys might be taking a break from math for now. So we are going with some easier problems today. All right. So you guys know the drill. Just send me your answers in the chat when you guys have them, and then I'll let you guys know if they're correct or not. Hmm. Let's see. All right, pop. Um, Ali, make sure you're. What is this stuff on my? Okay. Uh, Yeah, make sure you're reading the question correctly, I guess. Your answer is a little bit too high. Alice's answer is a bit too high as well. Um, yeah, I would say for this question, also make sure you're private messaging me your answer. Jingxi, I guess you're on the right track. Your answer is too low though. Rachel, your answer is also a little bit too low. Make sure you're counting, we're tossing two dice, not one. Ethan, that's a little bit too low. Charlie, that's correct. Uh, Layla, that is a bit too low. Ethan, that's also still too low. Alice, you went the wrong direction. Hold on, let me. Yeah, so Alice, you're really close. You went the wrong direction from your previous answer. Uh, Ethan, you're getting closer, but it's still too low. Sorry, there's like I spilled like water on my tablet thing that I used to write on. Let's see, Dylan, that's a little bit too low. Okay, so looks like a lot of us have gotten the chance to try this one out. Oh, sorry. There's someone in the waiting room. Okay, so since most of us have gotten like a chance to try this one out, let's start explaining. So for this question, we're tossing two standard six-sided. I can't draw straight lines. So we're tossing two standard six-sided dice, right? And we want to find the probability that you'll get a three on at least one die. So you can do this like two different ways. So I guess I'll go over like the slower way first. So in this case, you can just do null probability, and you can say like number of things that work over number of total things, right? A number of total things, we can just do a thing where we have like 6 times 6 equals 36 at the bottom. Because the first die is a singular form of dice. The first die has 6 options, the second one has 6 options as well, right? So in total, they have 36 options. So now we just need to find the top part of the fraction, which is how many different things that work. And things that work are the things that satisfy this probability. You'll get a 3 on at least one die. So we can actually just count these out, right? We can have like 3, 1, like 3, 2, 3, 3, 3, 4, 3, 5, 3, 6. Or on the other side, we can get a 1 and then a 3, which is different because we're rolling two different die, like dice, two different dice. 2, 3. 3, 3 is already accounted for, so we don't count it again. And then 4, 3, 5, 3, 6, 3. So in total here, we have 6 over here, 5 over here for 11. So the answer is 11 over 36. All right, cool. So this first way, we do like a common trick that works a lot of the time in these problems. So what we're doing is instead of saying we're just gonna toss two standard six-sided dice, we say we toss them one at a time, right? Because if we say like one at a time, it's a lot easier for us to comprehend the like the repeats and stuff like this where we have to only count the three case once if we say there's a first die and then a second die, right? So we assume one at a time and then we just take first die, second die, and then we can enumerate them really easily like this because it doesn't really matter if we're tossing them up at the same time or tossing the first one and then tossing the second one, we still end up tossing both. Um, this actually comes up a lot in different problems, so make sure this part makes sense. So the part where you're splitting um this tossing both at the same time into tossing one die and then tossing the other die. All right. So this, I guess the second way we can do this is by directly calculating using probabilities. So in this case, we can use complementary counting. So like counting what we don't want, right? So here it would be um so what's the probability that you don't get a 3 either time, right? So whenever you see language like at least one, then you know the opposite of this is usually none, right? And this is pretty easy to count most of the time. So whenever you see like at least or at least one or something like that, always look to complementary counting if you can't figure a problem out. But anyways, I digress. So to complementary count this question, we just need to find the number of ways, or we can find the probability that you don't get a 3. So if you don't get a 3 on the first one, that's 5 over 6. And if you don't get a 3 on the second one, that's 5 over 6 again. So this is the complement of what you want. So you take 1 minus 25 over 36, and then you get 11 over 36 again. So both ways here work. Yeah, let's see. Did I miss anyone's answers in the chat? No. I think good job to Charlie got it correct. So yeah, good job, Charlie. I would say the most common, oh, hi, Brian. The most common incorrect answer that I saw was probably 1 over 6, I think. No, maybe 1 over 3. I can't remember. But yeah, so I'll make sure we're counting this carefully here. All right, next question. Ethan, that's pretty close. You're a little bit off. Charlie, that's correct. Good job. Plus one. Jingxi, that's correct. Uh, Wonderful. I'm running out of like adjectives to say when people get things right. Oh yes, Alice, that is correct. Nice. Benjamin, make sure that you're not over counting. Like in this case, I know the last question I said you could like say, you could like sort of switch the two dice around, but in this case you can't because the two die are different. So, try again with that in mind. Yeah, that's correct. Good job. Rachel, that's correct. Ethan, your denominator was correct the first time. Make sure you're, um, yeah, that's correct now. Good job. All right. As always, feel free to send me your answers in the chat. If you guys are still working on like the problems as I'm explaining, and I'll be looking at the chat too. But anyways, we'll get started with this problem. So this problem is kind of like the other one in that we have two fair six-sided dice, but that's where the similarity ends, right? So one die has these numbers on it, these six numbers. I cut off and my tab. Yeah, so the last one's 11. And then the other one has these six numbers. And we want to find the probability that the sum is divisible by 5. Okay. So whenever we're finding something, the sum is divisible by 5, we can just take their remainders, mod 5, and then that'll work just as well because and what we're doing is we're just adding up remainders. So this is the same thing as saying if the numbers on the first die were 1, 3, 0, 2, 4, and then 1 again, right? So this is the first die, basically, because adding 5 to a number on the side of the die is not going to change whether or not it's going to be divisible by 5 if it's added to something else. So in this one, the second die, we have 2, 4, 1, 3, 0, and then 2, right? So you don't have to do this if you don't want to. I feel like this just makes it a lot easier for me to add the numbers together. So I did this, but you can always go with the original numbers if you wanted. Um, and basically what we're going to do is we're just going to go down the line and see just like if these match up, right? So the tricky thing here is we're not going to say each of these has a one-to-one matchup, well, because that would give me 6 over 36, which is not correct, because there's two twos on this side, right? So we have to go through and count. So here we have 1 matches to 4. So if we get a 1 first, we have to get a 4 next. So 1, 4 is an okay combination. 3, 2, and then 3, 2. So I'm just gonna write this like this to make sure we know that there's two of them. In actuality, it would be more like 3, 2, 3, 12. But yeah, I've represented it like this. And then up here we have like 0, 0, 2, 3, 4, 1, and then 1, 4, right? So in total here we have 7 different options. And then since we're rolling two fair six-sided die again, there's 6 options here, 6 options here. So we put this over 36. So the answer is 7 over 36. All right, cool. So a lot more of us ended up getting this one right this time, which is great. Um, I would say for this question, make sure there's actually a way you can cheese this question a little bit. So you're like, oh, there's 6 here and 6 here, and we're adding up. and seeing if they're divisible by 5. Since they're increasing by 2 every time, we can say, oh, it's going to hit every single one once, and it'll repeat one of them once, right? So for example, here we have 0, 1, 2, 3, 4, and then we repeat the 1. And here we have 0, 1, 2, 3, 4, and we repeat the 2. And then we're like, okay, so each one of these has one, but then one of these maps to an extra one over here because this has 2. So it would just be 7, right? And you have to be careful that these two don't match up. Otherwise, it would be 8, but they don't in this case. So it has to be 7. Don't worry if you didn't understand that. That was kind of me uh trying to be fancy while solving this problem. But yeah, most of us got that one right. So I'm not too worried about that question. All right, question 3. Yes, Alice, that's correct. Charlie, that's correct. Yeah, now that I'm reading the question again, like this question is a lot easier than I first thought when I was like picking out this problem to talk about today. Like I use some weird like choose functions here, but yeah, I understand you don't actually need to now. Yes, Ethan, that's correct. Jingxi, that's correct. Yes, Ali, that's correct. Good job. All right. Cool. So, for this question, I'll just start explaining now since like you get the trick and you can do it pretty fast or you don't. So, this question is, like I said before, easier than I thought it would be. So here there are 6 plus 3 plus 7 is 16 total books. Um, Benjamin, wait, let me check. That's a little bit too low. Yeah. So, if you solve it the easy way, like, um, then this question's not so bad, I would say. So basically, we want the probability that, okay, so the first book on the shelf is a math book. All right. So first of all, we need to be really careful and notice that both of these sections are actually math books. So there's actually 10 math books, right? Um, After you realize that, the first one, it doesn't really matter what all of the other ones are as long as the first one is a math book. So we can just this is sort of like the same thing that we did before with let me think. With the two die in the first question, where we're like, instead of saying we roll both of them, we can say we roll the first one and then we roll the second one. Here we can say we're filling up our bookshelf and we fill in the first slot first, right? So the first slot first has a probability of 10 over 16, which is 5 over 8, has a math book. And then it doesn't really matter what the rest of our bookshelf is, right? Because that's the only part we care about. So it's going to be 5 over 8. Um, I guess to help you guys see like why this is important that we assume this. Um, so let's say we started from the other end, we started from the back, and then we chose like a geometry book in the back, right? Then the probabilities here are going to be like all out of whack because we don't have as many math books as we did before, and our total pool is smaller, or whatever. So that's why we start from the front because it's a lot easier for us to think about, and the probability is 5/8. So if you're kind of dumb like me, and then you didn't see this, I guess what I did before is I was just like, I'm just gonna count like the number that we want over our total number. And that's what I did, and I ended up having this like really complicated choose function that probably would have given me the right answer, but it was very long and drawn out. So yeah, this is the easier way to do it. All right, cool. Question four. Okay, Ethan, that's a little too low. Charlie, that's a little bit too low. Alice, that's a little bit too low. All three of you guys have the same answer. So, uh, make sure that you're like you don't miss like a trickier square somewhere. Ethan, that's a little too high now. Make sure you're not like overcounting a case or something. Yeah, Benjamin, the same thing for you. Make sure you catch some of the trickier squares that are in the problem. Hmm. Alice, there are actually two kinds of tricky squares in the problem. So you accounted for one of them. So now you have to go find the other one. Charlie, that's correct. Jingxi, that's a little bit too low. I should start doing top three again. I forgot about that. Yeah. Ethan, that's still a little bit, well, now it's a little bit low. Uh, yeah, I'll just see if I can remember. All right. Talk. Alice, that is correct now. Good job. Uh, let me look. Okay. Benjamin, you're getting closer. Um, as so there are other than like the ones that like you probably saw at the beginning, the trickier ones come in two different forms. So try and see if you can find both of them. Um, Actually, no. There's not. Ethan, try and see if you can construct a square with side length square root of 2. Actually, I'm not sure where you're getting your dimensions from. Uh, oh, as in like vertices? Yeah. So I would not like count my squares like that because if you count your squares like that, it'll lock you into thinking about squares in a certain way, which is preventing you from thinking of the other squares. All right. So I'm kind of glad we went over this problem because this problem's like you see it once and then you're gonna be able to like know it for the rest of your life, but you're gonna have to get it one wrong once first. So I guess it's good we did it here instead of on the competition. This is one of those like trick questions where if you if you like get like if you know the trick, then you're gonna avoid undercounting. But if you don't know the trick, you're probably gonna get it wrong the first time. So here, we're gonna start off with the more obvious squares. So here we have these ones, and there's nine of these. One, two, three, four, five, six, seven, eight, nine. Right? All right. And then we also have these like two by two squares, right? Two by two. And I'm referring these to as two by two squares because of a reason I'll talk about later. So two by two squares, we can count them based on their center, right? So the center is here, 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 and here, right? So here, 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 here. So there's four of these. And then there's obviously one like three by three square, which is the big one. All right, so this is where a lot of you guys stopped, and then if you just stopped here, you would have gotten 14, which is slightly low. So the reason for this is because there's actually two more types of like weird squares that are designed so to like trip people up. So the first kind of weird square is this sort of diamond weird shape, and this is like a root two by root two square. I wish it looks kind of weird, but what can you do, right? Let me try and draw it better. Yeah. So if you again, if you once you see this question, if you get another question like this again, you're just gonna be able to draw in the little diamond. So I'm not too worried about it after today. But yeah, so there's four of these, right? So there's four. And then if you only counted these, you would have gotten 18, which is still a little bit too low. Um, because there is another like sort of sneaky square over here, which is a root 5 by root 5 square, I think. 2, 1. Yeah, it's a root 5 by root 5 square. And this one has not one, but it has two different options here. Ta-da! So, yeah, so just whenever you're doing questions like this, um, just pay attention to like where the question is in like your problem set. It's like if this is a math counts problem like 20 or 22 or something like that, the problem's probably going to be harder than counting squares. So make sure you're on the lookout for stuff that might be hiding in the diagram, like these bottom two cases over here. And that's how it shows up in a lot of different questions. So next time you see a question like this, just make sure you do that because I think I've seen this exact kind of problem in competition, like probably like five different times by now. So this is kind of important to know. But anyways, if we add all of these up, we get 14 plus 6, which is 20. Are you cool? Hmm. Yeah. Oh yeah. I was gonna say something about this. So the reason why I'd like to do like one by one instead of saying uh like saying that this is like a two by two with the vertices is because then you can't really say that this is not like a two by two, right? Because then it would also be a two by two because it's like two vertices by two vertices type situation. But it's really a different square. So that's why I like to use side length instead of vertices. All right, next question. This one shouldn't be too bad, I think. Jingxi, make sure you're not unnecessarily dividing by two. Charlie, that's correct. Alice, that is correct. Dylan, that is correct. Good job. Jingxi, that's correct now. Good job. Ethan, that is also correct. All right, so it looks like a lot of us have gotten this incorrect. So this one's just you have six different beads. Well, you have seven different beads. You have one a regular one, and the other ones come in pairs. And then you want to make a symmetric bracelet, right? So the idea for all of these symmetry questions is just one side determines the other side, right? And this is the same thing for like palindrome questions. Oh, I can't spell. Palindrome. You know the numbers that are the same like forwards and backwards? It's the same idea, right? So if you want to count the number of palindromes, you can just count one half because the other half is determined by the first half. So it's the same idea here. So we know that the odd one now has to go into the middle. It always has to go into the middle because otherwise we can't reflect it, right? So this is always going to be fixed. And then we're just going to take, oh, I ran out of screen time. Okay, I'm back. You guys can still see what I'm writing, right? Okay, cool. Yeah, so my computer ran out of screen time, so I had to give myself some screen time real quick. Anyways, um, back to what I was saying. So in this case, we're just gonna split them up. So you know how we have two, two, two? We just have split them up into like one, 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 and one, one, one on the other side. Sort of like how we have it split up like right now, right? So on this side, we can just choose the order it goes in. It can be like green, blue, red, like it is. It can be like green, red, blue, like red, blue, green, red, green, blue. Blue, red, green, blue, green, red. Okay, so that's all of them, I think. So there's six different possibilities, which is technically 3 factorial, which we could have done instead of counting them all out like I did. But so once you have these, you just reflect it over and they just determine the other half. So there's just six different options here. So answer is six. All right, cool. Next question. All right, Dylan, that's a little bit high. Jingxi, that's correct. Alice, that's right. Charlie, that is correct. Benjamin, that is a little bit high. Hmm. Rachel, that is a little high. Okay, so let's just do this question then. So we have five friends have their pictures taken. If they take pictures in groups of three, how many different groups of people can have their picture taken? So I feel like this is kind of most of the people who got this one wrong is it's probably just a like reading comprehension error and not like a math error. Um, Ethan, that's a little bit low. Yeah. So the answer for this question is just five choose three. I don't know if you guys like interpreted it a different way, but five choose three is just a number of ways you can choose three people to be in the photo out of five people, which is what the problem is asking, right? So this would be, well, this is the same thing as five choose two, right? Which is five times four over two, which is 10. So I don't know, make sure you're reading the question correctly, I guess. Um And it's also a good thing. Just to remember, like n choose m is just a number of ways that you can choose m things from n. That's kind of obvious, but I guess you have to make sure you can apply it to questions like this. So we're selecting three people out of five. All right. Last question for today. In this question, the formatting is a little cursed. So um, it goes like here, read this first, then this, and then you can hop over here and read that. So yeah, I cursed the formatting somehow. Um, Charlie, that's a little bit high. Alice, that is correct. Good job. Jingxi, that's also a little bit high. Ethan, that's correct. Good job. Rachel, that's also correct. Yeah, sorry. If I'm like already on your chat, it doesn't pop up as a notification for me. So if I don't read your answer, like don't tell if you're right or wrong, that's probably what happened. Jingxi, that's correct. Charlie, that is now correct. Right. All right. So this question is kind of just like make sure you don't make a silly mistake while you're doing it. Um, Make sure you're multiplying everything together correctly. Um, so wait, what time is it? Okay, in the interest of time, so we have enough time to like finish our countdown round. Actually, oh yeah, okay, I'm right. Okay, so if in the interest of time, in order to ensure that we have enough time to finish our countdown round, I'm just gonna tell you guys the answer because you guys probably know how to go through the process. Just some of you guys are probably just um making small arithmetic errors. So yeah, so the answer here is seven. If you didn't get seven, you maybe like added or you subtracted or multiplied incorrectly, probably somewhere. So yeah, just go through your chain and make sure you're I guess just like doing the math correctly. All right. But yeah, so we're just going to do our weekly countdown round today now. So we have 12 minutes, so we should have enough time to go through all the questions this time. All right, cool. So yeah, if we're ready, we can start. Alice, that's correct. Charlie, that's correct. Jingxi, that's correct. All right, talk. So the answer here was 48. Honorable mentions to Rachel and Ethan, who also got it right, but not in the top three. Okay, next question. Okay, let's see. I don't think anyone's gotten it right so far. No one's gotten it right. Unless I'm tripping here. Wait, hold on one sec. Yeah, okay, I'm not tripping. Um, yeah. Sorry, Rachel, I didn't see your answer. Oh yeah, Rachel, that's correct. I think I'm going to stop it there. Yeah. Okay. So the answer here was eight. Um, yeah, so for this question, basically, the trick to multiplying by diagonals is sort of like the same for counting what? I actually this I know I thought I had an analogy, but there isn't one. So the formula is n minus 3 over 2. So basically, for every vertex, you can connect to anything but these three vertices here. So it's n for n vertices times n minus 3 divided by 2, because each diagonal can go in two different directions. Yeah. Um, I think my answer key for this one is wrong. The answer is not in fact 17. I'm gonna go grab something real quick. All right, I'm back. All right, next question. Is Charlie, that's correct. Jingxi, that's a little bit. Oh, Jingxi, that's correct. And Ethan, okay. All right, so this question was just six, because we have three different numbers and you have to use all of them, so it's just 3 factorial. Honorable mention to Rachel, who also got it correct. Um, but unfortunately did not get it in time for top three. Uh, I am going to pull up. Here, let me see. Can I log out of this account somehow? Okay, no, I can't. Whatever. This is gonna have to work then. All right, next question. Charlie, that's correct. That was very fast. Good job. Jingxi, that's correct. And Rachel, that's correct. All right. So the answer here is nine. It's just a number of prime numbers less than 25. Because even if it's repeated, you don't count it an extra time. All right, next question. Oh, what the hell? Kevin's correct. For some reason I can't see Kevin's answers, so I'm gonna have to manually check that later. Uh yeah, so Kevin is correct. Charlie's a little bit high. Rachel, that is a little bit high. I think Ethan, that's very low. Albert, that's a little bit high. Alice, that's a little bit high. Charlie, that's correct. All right, so I'm just gonna stop it there at two. So so Kevin got it first, and then Charlie also got it right. But yeah. Yeah, sorry, Kevin. For some reason, because I need to scroll down to see everyone, so just wasn't scrolling down, so I didn't see your messages. Um, yeah, it is without replacement, so that's kind of unfortunate. But yeah, so the trick is it doesn't matter which thing the first one is, the second one has to be of the same parity. So if you get an odd number, you have to get an odd number the second time as well. All right, question six. Alice, that is not correct. Ethan, that's not correct. Charlie, that's correct. Okay. Kevin, that's correct. For some reason, okay. Rachel, that's correct. Okay, wait. So it was Charlie, Kevin, and Rachel, I think. But yeah. All right. So I actually was in fact not tripping. Okay, so this one is 10 questions. So it's not like you don't renumber them every day. So like on the first day you write question one, on the second day you write questions two and three. So on the ninth day you write up to question 45. So on the 10th day you write question 50 in the middle of the 10th day. Um yeah, so unfortunately Kevin, for some reason like your your messages aren't showing up as notifications on my screen. I don't know why, but I'll just keep you first so I can see if you send me something. All right, next question. Yes, Kevin, that's correct. Dylan, that's correct. Yeah, let's see if we can get one more. All right. Okay, so I'm gonna stop accepting answers now. So the answer here is actually going to be zero. They can't be the same because the sum of all the numbers from 1 through 10 is not an even number, so you can't split it 50-50. So the answer is just zero. It's kind of like a cheesy question. Um, but yeah. In the interest of time, I'll just do one more question. So you guys have one more chance to make the leaderboard. Oh yes, Kevin, that's correct. Jingxi, that's correct. Alice, that's a little bit high. Rachel, that's a little low. Ethan, that's correct. Good job. Um, wait, and Ethan, yeah. Good job. Yeah. So the answer here was, oh, I clicked on something. All right. Uh, all right, back to what I was saying. So the answer here was 54 diagonals. I accidentally gave you guys the formula for diagonals, but in case you forgot, it's n minus 3 over 2, like I talked about in question like 3 or something like that. So if you remembered that, then or you knew it before, then good job. It was just 12 times 9 over 2, which is 6 times 9, which is 54. But yeah, good job to everyone who participated today. Sorry, Kevin, for some reason. Oh, I know why. Because we're using the same Google account, so it doesn't count it as being a notification. Okay, that's kind of dumb. Anyways, um, technical issues aside, thanks everyone for coming today. I know it's been a while, so thanks for still being interested in math class. Um, but yeah, good job to everyone who got onto the podium. And Charlie, Kevin, and Jingxi for being first, second, and third today. Oh, all right. Bye, guys. Yes, I love math too. Adios.